those of you not joining us again, it's just funny if you're joining us to begin with. Who watches a person write software for fun? I don't know why people do this, but, it's interesting. Let's call it interesting. All right, it's A3, Advent of Code. Let's go. Here we go. Day 3, toboggan trajectory. Oh, by the way, it's been out for an hour and a half, so we're not anywhere in the leaderboard. So we're going to take our time with this one, and we're going to do it right. With the toboggan login problems resolved, you set off towards the airport. While travel by toboggan might be easy, it's certainly not safe. There's very minimal steering, and the area is covered in trees. You'll need to see which angles will take you near the fewest trees. Yeah, that seems fair. Due to the local geology, trees in this area only grow on exact integer coordinates in a grid. Isn't that convenient? You make a map, your puzzle input, of the open squares and the trees you can see. So for example, okay, so I got a pathfinding algorithm. I'm almost certainly in pathfindingville at this juncture. Those aren't the only trees, though, due to something you read about once involving arboreal genetics and biome stability. The same pattern repeats to the right many times. Okay, so we have, we're getting into a topology. Okay, this is a mathematics topology thing. Very interesting. You start on the open square. By the way, for those of you that are topology geeks, what shape does that make? I think that makes a cylinder, doesn't it? Yeah, or a ring. Yeah, it makes a ring that you can only do the outside of. But, yeah. But if the top and bottom start to connect, then it starts to make a torus. All right, this is exciting. You start on the open square in the top left corner and need to reach the bottom below the bottommost row on your map. Okay, so you start in the open square on the top left and you need to reach the bottom below the bottommost row on your map. Okay, that's interesting. The toboggan can only follow a few specific slopes. You opted for a cheaper model that prefers rational numbers. Right. Start by counting all the trees you would encounter for the slope, right 3 and down 1. Do what? Okay, I'm starting here. And I need to reach the bottom. So I need to get here and then 1 below it. I get that. In the top left corner, you need to reach the bottom. The toboggan can only follow a few slopes. You opt for a cheaper model that prefers rational numbers. Start by counting all the trees you would encounter for the slope, right 3 and down 1. This is where I'm confused, because to me, right 3, I would be 1, tree, 1. I would encounter 2 trees. The locations you check in the above example, it's just a slow, okay, you continue on that path. It's a vector. I get it. Okay, from your starting position at the top left, check that the position that is right 3 and down 1, then check the position that is right 3 and down 1 from there, and so on, and you'll go past the bottom of the map eventually. Got it. The locations you check in the above example are marked here with zeros, and there was an open square, and then X where there was a tree. Okay, so yeah, I'll get it. I see. Was a tree. In this example, traversing the map using this slope would cause you to encounter 7 trees. Starting from the left corner of the map and following the slope of right 3 and down 1, how many trees would you encounter? So a few things that this is just, there's no need to even think at this juncture, but this is, I know Eric's puzzles at this point, and I'm going to need to probably be able to hold this in memory, at least to some degree. I'm thinking that's going to be further down the line there. I think at this juncture, I'm just thinking about the y coordinate or the x coordinate, and the x coordinate is going to be just the width divided by the slope, and then it's going to modulo over. So you would do something like, let's say it was over 9, and the width is 8, and it's over 9 down 1. Then on line 1, it would be 0 plus 9. But 9 is actually the first item. No, 8 would be. So it's 0, 9. 8 is the first item. Should be the first item, right? So you want the index moduloed by 8. Or whatever, moduloed by 8. Yeah, that's it. Boom. I think that's what it is. Awesome. So let's get the input here, and we're going to put the input in this way. Input. Inputs day 3-1.text. All right. Input is in. There we go. And this is going to be, should be lines from file. Yeah, okay. Let's let, I don't think it needs to be mutable at this point. This is an interesting thing about Rust, because I'm thinking about like, oh, am I ever going to modify this variable? Which is just like, it's a stupid thought to have at this point. So, wish it was Python, then I wouldn't have that problem. Okay, so, looking here, let map, I'm just going to call it map, let's let slope equal I think, now I wrote a function for this, so we're going to go look at that function. Let's go to that function there. It's in, yeah, it's definitely in there. Line from file. There it is. Oops, that was a stupid mistake to make. There we go. There we go. All right, lines from file. Lines from file inputs say 3-1.txt. There we go. And then for line I, or it should be I and line, or yeah, line in slope enumerate. No, it's this. It's iterator, not enumerate. That's it. There we go. Now, in my little slope here, I'm going to say if, well, I mean, the crux of it is which character is it? So it's going to be, this is going to need input slope. Let slope x equal, well, whatever it is, 3. Let slope y equal 3. There's 3, 1. What was the slope? 3 and down 1. Yep. There we go. then you would just say, well, we're going to cheat. And I know I'm going to have to do this later, but we know the slope at y, it's 1. So we just do for each line, and you wouldn't do this if the slope was y or more. If it was 2, for example, that would totally change this. But since it's just 1, we can just take the line, unwrap. No, I don't think it has to be an unwrap. But, I don't think it has to be unwrapped. I think that's an actual string. Yeah. So you take a line, and then you want to do this bytes and then caret. We did it yesterday, so let's go. What did I do? It was cars nth. That was it. So here we go. Insert dot cars dot nth, and then this nth will be I minus, and this is where these types are going to be real pain in the rear. I think it'll work. I minus slope. No. I times slope x. It's I minus 1 times slope x. Yep. Modulo. Okay, now this is the length of a string, which I have yet to have to do. Rost length of string len. I'm going to say it's the len function, but I have no idea. Let's see. Is it the len function? Is it the len function? Let's have a chat. It's len. It is the len function. So I think that's a line above length. Boom. Okay, so if it equals a tree, then so I got to think more Rust-like. I really want a list of these. I see what I'm trying to do. So let's make it more Rust-like. Let's say it's, so I have a list line. Now on that list, I want to filter. This is where I do the list of vec filter Rust. Here it is. Okay, this is what I want to do. And it's not really even a filter, is it? Yeah, it is a filter. Yep, this is it. And then I say this Yank that. Oh, wait. Yank that. And I paste it here. Oh, that was unwelcome. And I put that. There we go. L. I think it's that. Ooh, but I need the index with the filter. Ooh, Rust filter with index. Looks like somebody has already come this. I click on the iterator at a specific index. Okay, that's something I want to do. Okay, I'm just looking up filtering here. Oh, filter does have, look at there. This is a power feature here for sure. Okay. You do this. Okay, you do a reference to a tuple that is that. Okay, that's interesting. That becomes X. That's the iterator. Slope X. Like that becomes X of length. If that equals tree. They give me those, and then okay, this is super functional. Okay, I'm really I like functional languages. Okay, here we go. Delete that. Delete that. Delete that. I pin that. What doesn't it like? Rust constant. I want a constant function. I want a constant. Here we go. Constant thing. You don't need let. Got rid of that one. No method named filter found for vec of string. Filter function Rust. What do you mean there's none? Do I have to do iterator? I think I have to do iterator. You gotta add iterator. That's what has to happen. There it is. Okay, now it doesn't like this. Mismatched types. What's mismatched? Oh, it's not going to tell me that. Expected struct string found a tuple. Okay. Rust filter. Okay, but I thought we could do this. Iterating over results. There we go. There we go. Oh, no. That's not what we want. Yeah, okay, I can do that. Oh, but it has to be enumerate. Ah, I see. So if I do you have to do iter dot enumerate. Okay. Okay, now I've got to figure out the count. So this is more like a Rust filter count. So I don't think you need the collect. So now I just have to construct a string. I think I can just do so that's there we go. Can't do that for usize. I know. Here we go. We're going to do that. Oh, take that out. Then we're going to do that dot u size. No. As I32. That's actually where we want that. Not too straight. Uh-oh. Slope Y is not used. That doesn't matter. I think we have it. Cargo build. Cargo run. Well, that's not a good sign. What do you reckon happened there? Well, okay, this is debugging, and I'm not sure what happened. Attempt to subtract with overflow. Okay, so I was 0. You don't have to do the -1. That's why. Because the index is 0, 0 index as well. Boom! 280 trees. 280 trees. Nailed it. That was great. Okay, now time to check the rest of the slopes. Now this will be the fun part. You need to minimize the probability of a sudden or arboreal stop. So that would be of a tree, arboreal. After all, determine the number of trees you would encounter if for each of the following slopes you start at the top left corner and traverse the map all the way to the bottom. Okay, determine the number of trees you encounter if for each of the following slopes. Okay, so what do right 1 down 1, right 3 down 1, right 5 down 1, right 7 down 1, and then this is the down 2, which is going to be the problem. So we are now going to do this and generalize this. Pub function count trees. This is going to take in a slope x, which who cares what the type is? Well, I gotta define the type for the variable slope x. Call it an I32. Slope y. Don't do that. Call it u size. U size slope y. Call it a u size, and then give it the slope. Yep. Which is a vector of strings that is then going to return to you a I32. Call it that. Now I'm going to go escape that. I've got to pull 6 lines, 6 DD E. All right, there we go. Now we don't need to do slope X or slope Y because we have it here. And we call that replace with, yeah, we don't have to replace anything. The slope okay, slope is borrowed. I don't think the filter actually changes the actual thing. I think you can just say that. Take this out. Check this. Here we go. Slope. We're going to borrow slope. I'm going to lend it to you. Pretty sure I do that. I think. Yep. And then from there, yep, as string. That'll do that. No longer need that. I no longer need that. I think I do need to dereference this, however. Oh, no, can't do that. Cannot count. Nope, nope. Don't do that. But I32 to string. U32. Well, yeah, well, same with that. I32. What are you talking about? To string, not as string. Jesus. Okay, there we go. Okay, there we go. That's not a thing. What's this issue there? Yep. That's fine. Let's try that. 77. Oh, for fuck's sake. Okay, so you need to multiply 1, 1, 3, 1, 5, 1, 7, 1, and then the 2. Three, 1. Five, 1. Seven, 1. And then 1, 2. There we go. Okay. You cannot find function, count trees. Where did I do that? Oh, there. Here we go. Flip Y is unused. Boot panicked. What do you think it did there? So I'm going to comment that out. Okay, so this definitely has to do with this. Okay, so now let's just take the 2 and insert boom boom there. Okay, now let's try that. Okay, it doesn't panic there. All right, so let's just. Okay, there we go. Now you're saying insert. Yeah, that's not gonna work. It was a lucky shot, right? Let's do this. We want to insert to string. There we go. It's not liking something here. It's saying expected one of. What do you mean you're expecting one of? You got that. Well, I think we just run this. It doesn't like that. It's just not. This is the comments. What? Rust multi-line comment. I thought for sure. I thought for sure. That. Oh. Ooh, interesting. I think it's just 1 star. It doesn't like the 2 stars. Okay. No, that doesn't matter. I don't know. I don't want to look it up right now. I think that works. Let's try this. Okay, that one worked fine. Oh, okay. Okay, let's do that. Comment that one. Try this. You do that. There we go. It's fine with that. Okay. So it's when we have a y slope of more that it doesn't like. This is it. This is what caused its panic. Why would this have caused its panic? It just ignores this. Panics on the 1 to 2. So what's happening on 1 to 2? Slope.iterate.enumerate characters. Int is I. That's the row. Okay. Times slope of x, which is 1. Mod x. Oh, what's happening here? Okay, so the int of the index, so that's the row number, times the slope of x. Okay. Now here's the thing. Now this is okay. I see what I got to do. So what's happening here? I just don't understand why the slope of x, slope of y 2 would matter. That's what I just don't understand what that matters. Why would that one be any different than this one? Don't use that second variable. Here's what I'm going to do. I'm going to say there we go. And we're going to do that. This doesn't make any sense. Given that, do that. Let slow b equal count trees. 1-1. And use slope. Let slow c equal count trees. 3, 1 at slope. Let slow CD equal count trees. 5, 1 and slope. Let slow ABCDE equal count trees. 7, 1 and the slope. All right, there we go. Boom. Easy as. Now, no, don't do that. Insert this. Oh, not that. This. Now we want to print Yeah, we're going to do it here. Print line. Why are you doing that? We want to print line, and then we're going to go boom, 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 boom. And that's going to be slow A, slow B, slow C, slow D, slow E. And let me just do string. Just do slow A dot to string. Gotta add that exclamation point. There we go. There we go. Let's see what happens. This doesn't make any sense. It doesn't make any sense. It's gonna be, if it's the size of the number, this is gonna be where Rust is gonna trip us up, because the int size. This is gonna be, this is where the stupid typing is gonna almost guarantee this is gonna be a type related issue. Yeah, it's a type issue. It's a multiply with overflow. It's overflowed because all these types. I need count trees as a bigger number. I need it as an unsigned 64. I need more memory. Need more memory, Captain. Use 64. And yeah, see, I would never have to do this in Python. Like, you would not do Rust to do this by speed, because there's, how would you even get into that? You know? Okay, so that should do that. That should fix that problem. That fixed that problem. Okay, that's fine, except little thing with our little filter. We want its equal tree, but we also are going to filter on another thing. And that other thing we're going to filter on is whether the y-axis is divisible. No. You need another one. Yeah, I get that. Yeah, I get that. All right, now we go here, append, and we want the iterator divided by slope. We want iterator mod slope y equal 0. So I think we have an answer. That's not the right answer, Alan. My answer is too high. Okay, let's look at this. Slope 1, 1. We're encountering 40 trees. Or 1, 2, 40 tree. No. Yeah, 1, 2, 40 trees. On slope. First off, that's the last one. A, B, C, D, E. Okay. If we can just do this again. $280 trees on right 5, down 1. Okay, I just gotta change the. It's getting cold in here. Alexa, turn the lights on.
Okay.
Okay. So what's wrong with this? You don't like that number? That's too high of a number. Just cognizant. So for answer 1, we got 280, and that was right 3, down 1. We're calling that slow B. But here, slow B is coming back as 77. This is not a mutable vector. This is an immutable vector, so this shouldn't change it, does it? Does Rust filter change the vector? Okay. Oh, it's just not updated. Okay, there we go. So there's that. 280, 74, 78. There's just going to be that 41. That's wrong. And why is it going to be that 41? That's wrong. Well, because you need to count the first one. Down 1. If it's down 2, it's I, so he's not at I. That's it. I plus 1. We count that one. I. So what do you think? It should be the first one, which is 0, mod the slope counts. Okay, 1 mod the slope of 2 gives back 1. It doesn't count. Line 3, which is mod slope of 2, that should count. Yeah, okay. Well, I think I got that right. I don't think that's, you don't think you do that. I'll just make sure that I'm not doing anything weird with types. Am I getting the right numbers? Okay. No, yeah, it's because the x-axis is not moving at the same rate. Right. So this is going to be and that changes just ever so slightly. That changed that last one, and that's our right answer. Almost certain. Yeah, that's it. It was, yep, very good. And that's day 3. Well, that only took, how long did that take? How long has the stream been going? What does it say? I have no idea how to tell this. Oh, here we go. 1 hour. It took me 1 hour. Oh, well. Well, learnings from there. So this is the first time we've used the filter method. So now starting to approach Rust from a more functional way of thinking, which is allowing me to do things pretty concisely without for loops, which is interesting. That's pretty neat. But other than that, I don't know how many people even watch this. I have no idea. But if you're out there, thank you for watching. And that's it. We'll see you tomorrow. Bye-bye.